Your next homework assignment's due on Sunday, and we're using the computers today. We'll also use the computers on Sunday. So it'll be a repeat of today where if you don't bring a computer or someone won't share with you, then you can't get the in-class exercise credit. In-class exercise credits for participating, and today we're going to be doing computer stuff. So if you didn't bring a computer, maybe you should try and find someone who did, and you can work with them. So do it again next time. Bring computers again. We're continuing on the interest factors section, 2.7, and specifically what we're doing today is we're trying to find out if the I is unknown or if the N is unknown. And so previously we've been finding what is the present amount, what is the annual amount, and so on, but these types of problems are a little bit different because we're solving for an unknown interest rate or an unknown number of years. So we're going to do that with a series of examples. Does everyone have the in-class exercise paper for today? All right. Well, we're going to start off with this first one. And in the first one, you're given a cash flow diagram. And let's take a look at this cash flow diagram. We can see that it appears to be a gradient at first, but then it's not exactly just a gradient. It's two things on top of each other. On the paper, I've given you a hint or a note. The note on the paper for problem 1 says, break the cash flow diagram into two parts, a P/A and a P/G. And so what we're saying is that this cash flow diagram is like the combination of two cash flow diagrams together. And what we could do is we could draw the arrows like this. So you can see that there is an annual series where the same amount is coming every period. And then on top of that annual series is a gradient. 30, 60, 90, 120. And so for this problem, we have an A and a G combined together. So any ideas on what the problem-solving approach for this is going to be? Okay, use both. How will you use both? You're right. But how? That's the details, right? You have? Go ahead. Okay. I think you're headed on the right track for sure. What it's saying is P total is going to be the P of the annual series plus the P of the gradient. So you combine them together. You say, I know the P sub A is going to be the annual series times some factor. And then the P sub G is going to be the gradient times a different factor. They're not going to be the same factors. All right, now look on the paper. Have I given you the table for 12%? So what can you do when you don't have the table for a certain interest rate? You can use the formula by calculating it, right. And so last time I gave you the equations that you can use any time. And does anybody have those with them today? The equations that are always valid? Both of these are kind of a doozy today. They're pretty complicated. You know, it was on the in-class exercise, although it's a bit small, but yeah, it's the second page on the notes from last time. In case you don't have it, I'll write it on the board. So go ahead and begin, and I'm just going to write the factor formulas on the board. How easy would it be to make a mistake writing this formula on the paper? Pretty easy, right? I think I made a mistake this morning. As I was writing the solution, you can see here, I think I had put squared instead of n. And I only noticed it when I was double checking. So you should always double check on a homework, and on an exam you should always triple check because the stakes are higher, you know. But so like we were saying, it's a two-part problem. First you find the factor for P/A. And actually, it doesn't matter if you do the P/A first or the P/G first. You know, when you're breaking it up into pieces, you can add one to the other or the other to the first. It doesn't matter. So what are the tricky parts to a problem like this? You tell me. I've been seeing these kinds of problems for a long time, so sometimes it's hard for me to look at it with fresh eyes, as they say. What's the trick? What do you think? Where are ways that a student could stumble? Okay, so finding out what's the constant amount and what's the g part. Yeah. Also, remember last time in class did I show you sometimes the g can be delayed? I didn't show you that? Well, look at this. What if we had the cash flow diagram like this, a slight variation on the problem? What if it was all right, what if it was 400, 400, 430, 460, 490, and this is year 1, 2, 3, 4, 5. So that could be a bit tricky because in this case, the gradient is actually starting at year 1. It's not starting at year 0 because we have 2 years where there's no gradient, and then the gradient, we start seeing evidence of it in year 3, 4, 5. So anybody have a solving strategy? If there was a problem like this, what would be your technique? Okay, of which one? Because remember, there's two parts here. There's the P/A and there's a P/G. Okay, so you were saying for the P/G, n equals 4. Now let's count that up. What do we know? The n starts when there's a, okay, so 0, 1, 2, 3, 4. You're right, n is 4. So if we wanted to find out what is the present value of this, how would we do it with the gradient? Okay. Okay. There's still one more step though, because if we did the gradient, if we did the P/G, it would take the money to here, right? Because here is your, you know, in terms of the gradient, you're 0, 1, 2, 3, 4. So it would take all of the money to year 1. So then what would we have to do as a final step? What is it? We would have to go from year 1 to year 0. Right, so we would do a P/F. So that's another example of how it can be even a little bit more tricky sometimes. Any questions from this problem? Yes? You got a question? Okay.
Why did you do that when it comes up with rights to think about
We do. These are all going to year 0. The thing in this example, though, is that both the A and the G are already starting at year 0. It's not starting at year 1. If you look, here is 0G, 1G, 2G, 3G. In this little sort of detour that I put on the board, we have 1G, 2G, 3G. So the 0G is there, and year 0, you know, it's sort of like a pseudo year 0 is actually in year 1. You know, from the perspective of the gradient, this is year 0. And so if we did a P/G, it would take all that amount to year 1. Other questions? All right, so now it's the time we've all been waiting for. We're going to do some computer stuff with this next example. So someone bought equipment for $60,000, and it's going to give income of $16,000 for 10 years. We want to know what kind of rate of return does that equate to? What's the rate of return if you make the one-time investment of $60,000 and then you're getting back $16,000 for 10 years? So the first thing, as you can see on the in-class exercise, You draw the cash flow diagram. Once you've got that, then I'm going to do the solution on the computer, and you can follow along typing the same things, just to get the first taste of how to solve this on Excel. It's hard to solve it? Yeah. Excuse me? We're going to do it on the computer, so it makes it easy. All right, so we spend $60,000, or rather the contractor does, and I got a good question as I was walking around. It's, should we always write the labels? And I think that's a very good habit. So let's put P equals 60,000, and then receives income of 16,000 per year for 10 years. So up is receiving money, cash inflow. We have 10 arrows going up, and we say A equals 16,000. All right, so what's the formula if we were going to try and solve for I with a P/A? P/A. Well, I guess it's right here, right? Okay, solving for I would be a bit tough, right? We can find, in this, we know A equals 16,000 and P equals 60,000. So we can calculate the ratio of the two, but then solving for I is going to be tricky. So let's do it a different way. Open up Excel, and we're going to put a couple of different columns on. Okay, does everyone have Excel going? Let me dim the lights a bit, just to make it easier to see. Okay. We're going to start off with, this first cell is interest rate. So we're going to have I equals, and that's what we're solving for. We don't know the interest rate yet. So we're just going to put in a guess value. Maybe it's 0.05 as our starting guess. Okay, here we're going to have year. And then for the next column, we're going to have the outflow. Here we're going to have the inflow. And let's just sort of type for the cash flow diagram what we already know. We've got 10 years. And it's only in this first year that we have a 60,000 outflow. And then the inflows here are 16,000. And if we just drag it down, it avoids having to type it all the extra times. So we've made a tabular version of the cash flow diagram so far. We don't have to write the units like dollars or dirhams. And just so we can remind ourselves, I'm going to put like a little arrow here that this is a guess value so far. We'll find out the real value in a minute. All right? So has everybody got that copied over? There's a really nice function called equals PV. And when you start typing a function into Excel, it gives you a hint of the format it wants to see your response. So do equals, now actually before, let's put a title, present value, just so we remember what's going into this column. We're going to find the present value of each one of these future amounts in terms of the interest rate that we've guessed. So in other words, money is less valuable in the future. We all know that, right? Because of inflation, it's better to have 100 dirhams now than 100 dirhams in 10 years. If we're going to get $16,000 in 10 years, it has a lower present value than $16,000. So the formula that we're going to be doing here equals PV, And look what it starts to do when you put in the parentheses. It gives you a hint of what needs to come next. So do equals PV and then the parentheses, and then it says rate. So what it's saying is, what interest rate do you want me to use for the present value calculation? We're going to point up here to this cell where we've got our guess value. And do you know how to anchor it so that when we drag it down, it's always looking in the same place? Dollar sign, right. The dollar sign will make it so that if we go sideways or down, it's always looking in the same cell. If we don't anchor it, as it's called, then when you drag down, it'll start looking in other places for the interest rate. So I'm going to push the F4 button on the computer, and it puts those dollar signs in automatically. See, it's got the dollar sign in front of the letter B, which means it's locked side to side, and the dollar sign in front of the number 1, which means it's locked vertically. Okay, so you could type the dollar signs in manually, but pushing F4 saves you that trouble. Okay, so now I put comma, and it's saying NPER. That just basically means N. In our case, if we want to find out the present value of a future amount, it needs to know how many years. And so right now we're in year 1. In the next row, it'll be year 2. So we're taking all of that money back to the present. So for N, I'm just going to point to here. You could type it in, but then that means you have to type the formula over and over and over. So it's better just to refer to where we've got the year. Should I anchor it? Why not? Yeah, we want it to change. When I drag it down, I should be looking at the new year every time. Okay, so I'll just put in another comma. Okay, so this is a bit tricky here. It's saying PMT means payment. We're not telling it an annual payment. This is a one-time future value. So I'm going to put a comma. I'm going to leave it blank. You just put another comma. Where it says FV and type, those are in brackets, which means it's optional. So you can switch between finding the present value based on an annual payment or the present value based on a one-time future value. And we're actually treating this like it's a one-time future value. So just put in another comma, and now it's highlighting the FV. And for the future value, I'm going to do this. I'm going to click there. But now, I love Excel a lot. It has one strange quirk when it's solving problems like this. It automatically changes the sign. It turns a positive value into a negative value because it's sort of saying if you want to have this positive amount, then you have to deposit. You know, it's always exchanging inflows and outflows. So I'm just going to put a negative sign in front of C5 there so that it can stay the same value, and then press enter. I don't want it to put the dollar sign here. I just want general. Now it has too many digits, so let me do currency. I guess dollar sign's fine. All right. So why is it less? So it's saying 16,000 in year 1. What does this 15,238 refer to? That's the present value of 16,000 in 1 year is worth 15,238 in today, if the interest rate is 5%. So any questions so far on what we've got? So what is your guess for what we do now? Drag it down. Very good. Rather than drag it down, I'm just going to click in this box in the edge, and then that's the same as dragging it down. So let me just click here. All right. So it pasted that formula through as long as it saw data next to it. It'll stop when it doesn't see any more data next to it. And then I'm going to find the sum of all this. So what is the total? So equals sum of all this amount. If if I had the correct interest rate, this would be equal to my original 60,000. So what I need to do is I need to keep changing the interest rate until the total inflow is equal to the original $60,000 investment. So let's see if I change it to 6%, if it gets closer to my goal, 0.06. Yeah, I'm headed in the right direction. So 0.07, getting closer. Okay, so do that. Optimize, like iteration is doing things over and over and over again. Keep changing that interest rate until you find out what is the interest rate that makes the inflow and the outflow equal. All right, I got a good question. When I was circulating around, someone said, why don't we just use goal seek? And that's a good question. Iteration manually is kind of tedious, right? 0.08, 0.09. We can do better than that. So let's see. There's data, what if analysis, goal seek. What we want is we want this cell to be equal to 60,000, and we're giving goal seek permission to change the interest rate. So let's see if this works. Okay, do it. And it plays around with numbers until it automatically finds the interest rate. Okay, so let me undo that and remind you where it is. Okay, you're starting in home. Go to data, what if analysis. And the what if here is, what if Excel did the work instead of me? So what if analysis, goal seek. So it needs to know two things. What is the goal and what can I play around with to manually iterate? So the goal is this should be 60,000 by changing the interest rate. And you tell it okay, and it works, and it finds the correct interest rate to a high degree of precision. All right. Any questions about that? So we're starting to enjoy Excel and how it makes our lives easier. Even more, check out this function. So this was the first way. We're calling this the PV function. We did the PV function. There's another one called rate. So just off to the side. So we'll call this solve problem another way. Equals rate. And it tells us what it needs to know. Okay, first of all, NPER, the number of payments. Okay, we'll just type this in manually. There's 10 payments. What is the amount of the payment? So PMT, 16,000. And then what is the future value? We don't know the, PV. Oh yeah, it's PV. PV is bold. So the present value was 60,000. So 60,000. And then we'll just end that with the close parentheses and enter. It's saying it can't figure it out. That's because it needs to have one of the cash flows be an inflow and one be an outflow. So the outflow was 60,000. We'll put the negative value there. Hopefully now, 23%. What about some precision? All right, so equals rate. And that saves us a lot of extra trouble if we can just do the whole thing in one function there. Now remember, I've recorded all of this, and so if there's some little trick you didn't see because I did it too quickly, you can just watch the video later on. All right, we've got a little bit of time to try this last one. You're going to solve the last one using the factor table, and then I'm going to demonstrate in Excel a similar approach. Okay, so problem 9.3, we spent 60,000. The income is $8,000 per year going on for an indefinite amount of time. We know the interest rate is 10%, so how many years until this contractor has recouped the investment? has gotten back the 8,000. It's not as easy as just adding up all the positive cash flows, because we know the future money is worth less in today's dollars than the 60,000 that was spent in year 0. So I step you through the process in A and B. And I have provided the 10% table at the bottom of the page. So go ahead and give that one a try. Okay, so for problem 3, you start off by knowing A is 8,000, P is 60,000, and you can find the ratio A/P is 0.1333. Now you go to the table. In the column that is A/P, you go down and you find out when is that ratio equal to 0.1333. And if you look, it's never exactly that. So by year 14, the ratio is too high. By year 15, the ratio is too low. So what is the interpretation of that? What does that mean that in year 14 it's 0.131, in year 14 it's 0.135, and year 15 it's 0.131? What that means is in year 14, he's very close to breaking even, but still has a little bit of debt. You know, not all of the income has been, not all of the original investment has been recouped by year 14. But then by year 15, finally it's recouped and is making additional profit. So the answer here, since the income is coming one time per year, we don't need to interpolate and find, 14.32798, because the income comes only one time at the end of each period. So it's by the 15th year that this contractor has broken even. All right? So let me demonstrate that on Excel. A different way of looking at it. Okay, so here I'm going to have the year, and then I'm going to have the amount. What did I call the headers before? Inflow, outflow, inflow. All right. Year, outflow, inflow, PV, and cumulative. All right. Here, in this next problem, I know that the interest rate is 0.1. That's given. Okay, so we have year 0 through just ongoing. We don't exactly know how long this one's going to be to begin with. Well, we do because we solved it, but let's just pretend that we're starting from scratch with Excel. All right, so the outflow to begin is 60,000, and then there's an inflow every year of 8,000. Okay, we've already learned the PV function, so equals PV. It's going to be our interest rate. I'm anchoring it here by the F4. The N, which is whatever year we're in. It's not a payment. This is a future value. And remember that I'm going to put the negative sign there because otherwise it just sort of always flips the amounts. So let's drag this down. So cumulative is looking at how much in the red, or how much debt is there so far. How much of the original inflow is unrecouped. So I'm going to do equals the negative of that. Okay, so in the first year, he's spent 60,000. What about at the end, at the beginning of, at year 0 at 60,000? So now it is going to be the previous one plus that. Okay, so it's getting a little bit better each year, getting the money back, getting the money back. And so the question is, when does that go and cross 0? We can see that it's the same answer as we got from the table. In year 14, there's still a little bit of money that hasn't been recouped, but then in year 15, this contractor is making a profit. Yes? Okay? formula? Sure. So starting here or starting here? Let me dim the light so it's a little bit easier to see the screen. So what we're doing in this PV column is, the contractor is getting $8,000 every year in the future. What's the present value of that $8,000? Because that's what we want to balance against the $60,000 that the contractor invested. You're giving your precious money today, but that money in the future isn't worth as much as your money today was. And so that's why we have to find out what is the present value of those future amounts. That's the purpose of the PV column. So then the cumulative, it's like a running total. How much unrecovered investment does the contractor have? Starting with the $60,000, and then everything after that, you're just combining the previous year with the amount that came in that year. And so you can see the debt is gradually going down, 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 and then finally, in year 15, the contractor is recouping the original investment. All right. So, as always, I'd like to collect your in-class exercise. Be sure and I'll pull the chair out so you can put it on there. Let's take a look at these announcements. Your next homework assignment is due on Sunday. If you use Excel on your homework, just to double check your answers, that's fine. But if you want to use Excel to, solve something, you need to print it out and show your work. And so don't just write on the homework assignment, solved with Excel, I equals whatever. That just doesn't show that you did the work. So I'll just, now that we're using Excel, make the announcement that you should always show how you solved things. And bring the computer again next time. We're going to do even more stuff with the computer when we get together next Sunday. So I hope you have a great weekend, and I will see you then.